and we're recording this fine Thursday. It's gonna be a good day. Right, so before we get to the project that I actually want to focus on today and tomorrow, that is going to hopefully wake up you guys' spatial skills, get those going. On the front of your desk, there's clipped a page that looks like this. You guys see this page? Okay. You might remember at the tail end of yesterday, last few minutes, I gave you guys a handful of trig notes that look a lot like these on this poster on this wall over here. Okay. You guys see my red laser pointer on the far wall. Okay. And that's going to be one of our big focuses next week, because trigonometry vectors is going to be pretty foundational to the class. You guys are going to see those over and over as the year goes on. But I know there are probably a handful of you guys out there who are like super hungry to get your hands on some of this material and start working on that. So I am giving you guys this page prematurely, just so you know. This is really next week's stuff. I really plan to give you guys this next week. But if you really want to look ahead and get your hands on this and try some of these out, then you can. The point of this page is, if you know a little bit about a triangle, can you figure out everything else about the triangle? You know, some angles, some sides, something like that. Okay. You should be able to work your way around the triangle, be pretty comfortable with that, especially within a few weeks. Okay. Actually, if you pay real close attention to this triangle, I mean, at a glance, it looks like a right triangle. It is a right triangle. Okay. If you look really close, it's actually, doesn't this look like a vector that's broken into component vectors, just like I drew yesterday? Looks like that, doesn't it? Yeah. Okay. Then on the other side are 5 triangles and a table. The point of this one, we eventually get to it again next week, is to apply a science aspect to trigonometry. Now, the math part would be, okay, you got sine and cosine, and you punch in some numbers, and it gives you a magic number, and it's probably right. I mean, it's pi, I guess, right? But you must know the ratios, what sine and cosine of all these different angles are. The science aspect is always, what do your observations and measurements have to say, right? So hopefully most of you guys at this point in your lives know how to use a protractor, but if you don't, then that'll be right, because I'll take you guys through this next week. You guys get to make some measurements with a protractor, measure angle sizes, break out a ruler, measure some of these lengths, compare those with the calculation, say, what does the calculator say to be, what does my actual observed measurement say, how closely do those align, and if there are different methods for determining what side should be, based on other information, are there certain methods that maybe tend to be a little bit more accurate than other methods? So that's a sneak preview right there. The other reason I wanted to give you guys this prematurely is you guys probably saw, looking at the syllabus, and I want to remind you guys the rhythm of this class when we eventually get it going, which can take a couple weeks, is that we go topic by topic. Every topic takes about 2 or 3 weeks, and per topic, so every 2 or 3 week cycle, right, we're going to have 1 or 2 labs. We're going to cap it with a quiz to make sure you guys give you guys something to study for, and prove the fruits of your studying labor with, and also give you guys some kind of independent homework assignment to work on. I think I told you guys too that I like to throw all the solutions out there too, so that you have this to fall back on. And there's the correct way to use those, which is try it yourself, and then if you're stuck, or if you want to check your answer at the end, get all the way to the end, then you'll have the solutions on standby to be able to do that. But the other reason I wanted to do this is this right here is probably only going to take us a few days, maybe a week, right? And so that's kind of a fast turnaround, especially if you guys might remember the very first day of class, one of the slides I had on my presentation was, I want to try something different with the homework. This is way too big for this projection, but I'm also recording this on video, so if you're watching this on video, then just to remind you guys, this is one of my slides, modified a little bit. All right, now I've never done this before, so you guys are going to tell me if this works or how this works, or even if maybe you're curious to even try this. So give you guys some options about what to do for this homework that you guys get every about 2 or so weeks. Okay. So probably the most straightforward thing to do is you guys some assigned problems, you just complete those, turn it in, and you get the credit. That's what I've always ever done. If you just want to do that, then that's definitely an option. You just do that and move on your happy way, and you know how to do it, you proved it. So there you go. Okay. And I'm thinking probably this page right here, maybe this is probably the simplest homework I'll ever give you. But again, it's like so foundational to so much stuff we're going to do that pretty good one. Okay. But I bet there are probably a handful of you out there who are looking at some of these other options and saying, I could have the opportunity to create YouTube videos, maybe get a pretty decent YouTube channel going. Like that comes with a whole set of skills I could build. I could build presentation skills, editing skills, all those things. Or maybe I want to do one of these other things, like a 2-page summary that I could clip together in a book that I could share with my classmates when everybody's reviewing in April, right? Or for that matter, like put a poster together and I create some models over here, including like that would be a pretty good model poster for what we're doing next week, right? For the notes I gave you last 5 minutes yesterday. So, yeah, Dan, giving you guys this, these materials a little bit prematurely, or they've actually been on Google Classroom too. If you guys probably noticed that, if you've been exploring those materials. But that's next week's focus. Let's move on to today's stuff, what we're actually doing today. So, again, I want to take today to open your guys' spatial reasoning skills, think about how to put things together. A couple of options, what we could build. It's going to take today and tomorrow. Option one, this is called a Geneva drive. Again, all we're doing is just paper and glue. Paper and glue, you can put this together. So you see what I'm doing is I'm hand powering one of these gears, and it's causing the other gear to turn incrementally like this. You guys see that? Right? Maybe the gear in my right hand that I'm actually hand powering, maybe it's connected to a motor. Right? It's turning like a ceiling fan. It's just just turning like real simple motion. Right? This incremental motion. What could this specific mechanism? Again, it's called a Geneva drive. What's one possible application you could think for that? What kind of machine might that be in? Yeah. A car? Yeah, maybe a car. Clock. Clock. Oh, yeah. You know what? I bet there is something, maybe that in a clock. Yeah, so that's a good idea. So Mauricio is saying a clock, right? Yeah, because you have like secondhand, create that ticking type motion, couldn't it? Right? That would be a great place to put that. I bet one of those is in there. What else do you guys think? Maybe could be something like that. Here's an idea. Maybe I don't know on the next one is you guys ever watch a TV show called How It's Made? How It's Made, yeah. So all right, if you haven't, they show like some product like how was this calculator made? How are these scissors made? I mean, some manufacturing process that came out of the Industrial Revolution a long time ago. And there's always like some little mechanisms and parts, and you pump up some materials, and some products come out the other end sort of thing. Right? I wonder if maybe a Geneva drive or something like it is used for, say you have a line of bottles, you got to fill them up with like I don't know, water, soda, something, right? And so like next bottle, fill it up. Next bottle, fill it up. Next bottle, fill it up. You could do something like that. Right? I do know actually one specific place this Geneva drive is used, and that's like the old projectors and maybe even VHS technology. If your parents have some VHS tapes lying around, like, let's say you go into an old cinema, the old black and white days, like everything's black and white. Right? You walk into the cinema and you see the reel gone, and what do you hear? Do you hear? You guys hear that? Right? That click sound? That's one of these. Because what it's doing is it's taking a roll of film, it's turning into 30 frames per second. That's one of these right here. Okay, so that's option one. We can put together one of those if you guys want to do that. Okay, option two is this table. Right. Oh, great, we're gonna make a table. Oh, that even looks wobbly. Why would I want to create a wobbly table? Well, I'll tell you why we want to create a wobbly table. Because this thing almost looks like it's levitating, which is super awesome. Pay real close attention. I'll turn this to the side for the camera. Right. Then the columns that are holding this up, well, actually, they aren't really holding it up. Not really, well, sort of, halfway. Each set of columns, like 3 and 3, are only attached to one of the bases. They don't actually go all the way to the other side. What's actually holding this up is something with a string. Yeah, there's actually tension that's actually holding this up. Tension. Right, it's called a tense gritty table. Okay, tense gritty. All right, so those are your two options. You guys got your phones out? Your phone's out and connected to the internet. Okay, so we flip my screen over. While you guys get your phones logged on, ready to go. I've got, okay, so it's not that link. I have to reset those stuff last class. Well, straw poll. Okay, let's create a straw poll. Create one from scratch. Okay. So, called project. Okay. Option one is Geneva drive. Option two is tense gritty table. Create poll. Okay. And then let me take this link and blow it up real big so you guys can actually see what's going on. Okay. Here's you guys' link. Okay, so give you guys a minute to vote on that.
If we do the table, we give us a.
Oh, yeah. Good point. Yeah, to make the table, you would need string. So one of my classes earlier, the other AP class actually, did opt to do the table, and we hadn't quite got to the string part. That's actually the last step. But if you guys do that, then I'll bring some string tomorrow. Okay. I do not have a due date on the homework yet. Um, at the earliest, it would be next Friday. That probably wouldn't be too unreasonable, but, again, I do want to take you guys through that. So if you think you can figure out, all the tricky stuff, which a lot of guys probably can, then that's all right, go for it. If you're struggling with that, then I do want to take a class over it, next week, so there'll be time for that. Okay, not working for everybody? Yeah, but I was hearing that from a few students last class too. We work for most students, but not everybody. Alright, well, you guys see what the results are. Yeah, sorry if you couldn't vote though, because a couple guys not working for it. Let's see. Um, all right. Looks like, well, Geneva Drive is out. So let's do Geneva Drive. Geneva Drive. Uh, sorry. Actually, since it was really close, let me see real fast. Who was trying to vote but had tech problems and you couldn't vote? You couldn't vote. All right. What do you want to do? Yeah, you want to do? You want to do? Drive and the drive. Okay, so it's okay. So it's still close, but it's still gonna be that conclusion. Okay, so all right, so let's do the Geneva Drive. Yeah. Get a good look at this. Okay. Now, how I normally like to do this project is to just throw a bunch of materials at you guys and say, figure it out. That's probably really the best thing to do. Um, I'll go ahead and put this together with you guys so that if you're not quite sure what to do, you're struggling, then you can just follow me and you'll be all right. Right. But yeah, if you guys want to go off-roading and do things in a different order or do things differently than I am, then please do. Try it out. Go for it. Right. Now, there are certain specifics about this that maybe do matter or don't matter. Oh, yeah. Okay. Yeah. Please. Okay. Yeah. Oh, actually, you know what? It's probably skater back. You want me to do that? Oh, no, it wasn't checked out in the first place, or still wouldn't do anything? Okay. All right, so there are certain details about this that maybe do matter or don't matter. Let me give you guys an example of something that maybe isn't super important. See how I have 8 teeth on this one? Okay, that's not really especially important. If you want 5 teeth or 6 teeth or like 2 might be kind of tricky. You can have 2 teeth. Got 2 teeth. Oh, nice. Probably not. No one aspires to have 2 teeth. But what could be an important, actually, what is an important aspect is that all these teeth are evenly spaced. See how like the number of degrees between each adjacent tooth is exactly the same all the way around? Okay. See if I didn't have that, if I had like 2 teeth that were close together and then far apart, or something like that, then when this other gear is rotating, one with the pegs, it's not going to catch them evenly around and around, right? So think about that. Right? Speaking of this gear with the pegs on it, I have one central peg that I'm using to hand power. Okay, so we definitely want that one, right? Unless you guys can think of another way to hand power it, but I guess probably a pretty good way to go. And I have 3 pegs that are catching the teeth. Now, there's nothing special about 3. You can have 1 or 2 or 3 or 4 if you want. Right? Now, if you do have 1, it could possibly be lopsided a little bit, like center of gravity could be moved. If you have 2 pegs that can catch, or like I have like 3, see how the center of gravity comes back to the middle, right? So it helps keep it a little bit more balanced, right? That's a nice feature, right? And then thinking way ahead, as this thing is finally coming together right at the end, after we have our component parts and we're ready to pop this all together, right? Notice how when one of these pegs leaves the gap in the teeth right here, so see how it's pushed it and it's moved, it's left. Okay. See how the next gap is exactly in place to catch the next peg? Right, you guys see that? All right, so that has something to do with how these 2 gears are spaced, right? Like the center to center distance. Right? So what we'll do is we'll construct one, we'll construct the other, right? But then when we're gonna set them in place, we gotta there's some exact position relative to each other that we gotta put them, like that, right? All considerations. And you know what? You guys know what you're not seeing. That's probably an important part of this too. Is how are these things actually spinning? Right? Oh yeah, maybe something underneath.
Don't spoil it.
Oh, I like that suggestion. Don't spoil it. All right. Yeah, let's do that one. You guys think about this. I bet you guys can figure out how those are spinning. What did I put on the bottom to make those like stay in place, stay fixed in place, but also spin? Okay. All right. So we need a couple of circles, don't we? A couple of circles. Okay. Now what's probably the tool that's built to make circles? What's that called? Called a compass. It's called a compass, right? Not the one with magnets that reach north, but it's one that looks like this. You put down one and then like trace a circle, right? What's really nice about that tool is that you can make whatever size circle you want, right? Now I don't have a compass with me. The tools that you guys got on your desk are these tools here. So what's another way you guys can make a circle?
My round water bottle.
Oh yeah, if you got some circle like a water bottle, yeah, yeah, you could use that. That quite a few students like to use the protractor, right? So I'll make a circle using two different methods, and then if you want to use either one of those, or if you want to use your own method, then go for it. Right? So I'm going to use this protractor as a compass. What I'm going to do is park one. See this node right here? Now, most of you guys have this style. Some of you guys have a little bit different style protractor. Right? I'm going to park this node exactly here, just keep it in place with a pin, right? That'll be the center of the circle. And then I'm going to take this corner right here, I'm going to trace that all the way around, and that should create a circle. Okay, create a really nice looking. Right. So that's one way to do it. Right, like that, really nice circle. Right. And if you think about the definition of what a circle is it just a bunch of points that are equidistant from the central point? Right. So keeping that in mind, show you guys a completely different way to make a circle. Right? Is I could use the ruler. Right? How could you use a ruler to make a circle? Well, if you're looking for a bunch of points that are equidistant from a central point, then I wonder what the radius of this circle is. Maybe I want to make one that's the exact same size. Right? So this circle has a radius of 5.5 centimeters, right? 5.5 centimeters. Right? Maybe I'll come over here to this part of the paper. And I'll make a bunch of points that are 5.5 centimeters from that point. I'm just going to go around. Now this is a little bit more labor intensive than what I just did before, protractor. But I'm going to mark a bunch of points that are all 5.5 centimeters from that central point. And that'll give me a circle that's the same size as the original circle. Your circles don't have to be the same size as mine. If you want to do bigger or smaller, then go for it.
You're making a huge one.
All right. So now I got a bunch of points, and all I have to do is go around and stack them with a smooth curve. That should give me a pretty good circle. Something close enough, anyway. Right, there you go. Two different methods, same size circles. So I'm gonna cut these out. Oh, you guys are catching up.
You got 2 days to do.
Yeah, today, tomorrow. Okay, 2 days.
The band kids are gonna be gone.
Oh,
None of us are
okay.
here.
How many guys are in band? Who's that? Oh, okay, so that whole corner class right there. All right, I feel like this class can be lopsided. It's a whole building here. All right, yeah, thanks for letting me know. So, yeah, sorry you guys gonna miss half this, but I'll give you credit anyway. Though. Yeah.
Did any of your classes make a deal?
Oh, yeah.
Yeah, my second period class opted for the table. So, it's also gonna take 2 days for that.
We're switching class here.
I don't see why they couldn't make us second period.
Okay, so now that you guys got a couple of circles, or getting pretty close to that, all right, think what we're gonna do with those. Go back to the model here. Right. So, gonna do something different with each one. Maybe I'll look at this one with the pegs on it that I'm hand powering. Okay. Yeah, I'm gonna make that one first. So I need, it looks like a central peg that I can actually hand turn, and then 3 pegs that are gonna catch these teeth, right? Huh? And how can I make those pegs? Like that's a cylinder shape, right? Like a cylinder, right? Huh? So how could I give a cylinder shape? What do you guys think? Oh, yeah, yeah. Derek said if you take a rectangle, you roll a rectangle up. That'll do it, right? Yeah, let's definitely do that. Let's do that. Right, so, now I do need a few pegs. I think what I'm going to do to stick in Hello's up is make a very long rectangle, make one giant cylinder, and then after the fact go cut, cut, cut. If nothing else, it's going to be like a uniform size cylinder, right, all the way down. So let's get a rectangle going. If you want to measure this with a ruler before you cut it, it's probably a good idea, but I'm a craft master. Okay. And then take a pencil and roll it around the pencil. Well, unless you have a better way. I do not have a pencil, but I have an ink cartridge. You can use that. I do have a bucket of colored pencils over there. You guys are super strapped on materials. Oh yeah, use as much paper as you need. Now, all the glue bottles are out there, and I have the one glue bottle has a terrible top, so I'm going to use a special glue brush. Like that, yeah. Yeah. Now you guys want to put on an optimal amount of glue. I mean, this is sort of an optimization thing in terms of the glue, right? If you put on too little, then well, that won't be good. But it's kind of hard to put on too little glue. If you put on too much, then it's going to take extra time for it to dry, right?
Pencil that nobody likes.
I found the house.
All my pencils are hanging on the road.
Yeah.
Hold on. We're going. It's gonna have a blue on it.
That's fine.
I know. I'm on the roadway. You can't ruin this.
Julia. It's been mean because.
I like to.
No.
Wonder why I like them.
Oh, good. No, wait, I didn't need it. Come on. I need another haircut. I can repay you for it. I have some.
Oh, there's the table, proofread table, actually, start with the paper, put it in quarters, you have a quarter page, and you cut that into thirds, and then roll those up. Okay. Yeah. Good job.
Hopefully this dries. I don't think it's. Hey, why is it doing this today?
All right. How many pegs do I want? Think about that. 1, 2, 3, 4. Yeah. 4 pegs, I guess. Alright, so I have some cylinders that I can use as pegs. Somehow I've got to attach this cylinder to this circle to make a peg gear. Now, if I do it this way, if I just throw down a ball of glue, let's say I want to make that central axis, right? I throw down a ball of glue, go stick, right? That's probably gonna take a while to dry, right? Guys, what's gonna dry faster? Here's your options. See my two hands? Let's say there's 2 pages of paper, right? If I do like an edge to surface connection, let's say throw down a line of glue, do edge to surface, or if I do like a surface to surface, which one's gonna dry faster? Definitely surface to surface. So, if I could somehow modify this so that I could get a surface to surface connection, that would dry really fast, wouldn't it? How can I do that? Yeah. Okay, I see a few of you guys all saying the same thing, which is, hey, like, cut feet into this thing. So, cut, 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 cut.
Yeah, I love it, but like,
Got a few feet?
I'm trying other things.
Yeah, if you're trying other things, that's definitely great too. I heard a suggestion earlier to like cut a separate rectangle and then glue it that way. Do you have another way to do it? Or okay, yeah.
I'm just making cylinders and then just putting straight up glue on the bottom of it.
Okay, so you're trying to edge the surface connection?
It's a roll. So it's like
alright.
there's enough surface on here for you to take it off.
Okay. Well, if it works, it works. So go ahead and try that and see what happens. All right, so Yeah, throw down.
Killed my pencil.
Yeah. I saw it behind. That sounds like the marching band. Like 2021. Oh, I have to measure mine. I want to see some baby.
When he does it. Okay, it's like a lot of movies where it doesn't talk. He doesn't have a voice.
No, it's 11 by 8.
Okay, I'm gonna kill every baby. Very satisfied with Laura when we recorded it. No, John, I wasn't even talking to you, I was talking to Riley. Okay, okay.
How long should I?
So, you'll take care. No.
Yeah, I didn't think of that, I'm just gonna come. Oh, there's glue in here. Sorry, I was just wondering.
Like engineering?
Yeah.
That makes babies.
Yeah. Did you make it? I think it was summer.
This is what I
Why?
Oh, that's pretty awesome. Yeah, that was
Oh my good crowd. Like, some crowd walking. No.
How many have I put together? Two. I think I came out with this idea 7-8 years ago, so about every year since then. Yeah, I do have like other gears and projects to put together, but this particular model takes pretty much exactly today and tomorrow, so it's a good one.
I know I should do that.
All right, now when you guys are gluing down your pegs, there's maybe aspects of gluing them down that's important or not important. See, if I glue them down in a place where they're not like equally spaced from each other, like right there, that's well, maybe okay, well, as long as they're not too close together, if they're not like fighting over teeth or something, right? I mean, they wouldn't spin it regularly. If you want to spin them regularly, then make them, evenly spaced. What is really important though is that they're all equidistant from the center, right? Or if you want to think about it this way, equidistant from the edge. So if there's like a centimeter right here, there's like a centimeter right here. This one's got to be about a centimeter from this edge. Okay. That way, when they catch the teeth, they'll all catch at the same spot.
Yeah, that's right. Thanks for repeating. I'm sorry. My plan failed. I'm doing this. I'm putting legs on.
All right. Good try to take some
Legs.
You just make a cylinder and then attach another rectangle to it.
No. So.
I didn't go to that because I didn't think about it. Yeah. Oh, okay, I would too. I think I'm sending everything that you know. I just have to keep everything. Yeah, right, one way. Okay, well, that makes sense. Keep it bold.
All right, so you guys making really good progress so far. Well, a little bit different spots, but I'm gonna go ahead and move on to the next part. Now, this bit I've been putting together still needs that piece on the bottom that I haven't quite revealed to you guys, but you guys have figured out maybe how the axle system works. I'm gonna put that to the side and start building the other one. Now, the other one, remember, has teeth. Okay, I'm bring out the model so you take a look at this. Right, has teeth like this, right? And the model has 8 teeth. That's not super important, but what is important is that they're evenly spaced, right? So that these pegs will catch those teeth at even intervals. So think about how many teeth you want. Maybe I'll put 6 on mine. I'm gonna have 6 teeth. Right? But however many teeth you want, if to get something evenly spaced, how could you do that? How could you give them exactly evenly spaced? Who said protractor? All right, good call. Yeah, Xander's saying protractor. All right. So because that could be a measuring tool where you can measure angles, right? If you want to measure angles. So if I want 6 teeth on mine, then I should take the circle and divide by 6 probably. Right? Now, how many degrees in the circle? 360. What's 360 divided by 6? 60 exactly, right? Okay. Yeah. So I'm going to put a mark where I'm going to have my first tooth, and then I'm going to measure out 60 degrees from that mark. Actually, while I'm at it, if you have an even number, like 6 is an even number, you could just shoot straight across and get the tooth that's going to be 180 degrees from that. Right? But then you just split it up into, so 60 degrees. Now, this protractor, probably most of you guys have used this, but if you haven't, then it's got 2 sets of numbers. It's got an outside and an inside. One goes clockwise, one goes counterclockwise. So 60 degrees lines up also with the number 120, like 120 degrees, depending on which way you're going. Okay. Then I'll go to the other, like 60 degrees from that, which is a 60, 120. Right? So 60, 120, 60, 120. Okay. Then flip it around to 6120, 6120. Okay. So now I have 6 marks that are exactly evenly spaced to the nearest degree. And I'm going to cut teeth at those places. Right? Now, if you want to, it's probably a good idea actually to do this is to measure maybe a centimeter to right, centimeter to left, make some marks that you're actually going to cut. I'm just going to eyeball it, go cut, just do it all the way around, try to make it probably as even as I can. Okay. Now, when we're finally putting this together at the end, and this will be tomorrow, right? If the gaps that you cut are not exactly right, if they're a little too small, you can very easily go back and just cut off a little bit more paper, make them a little bigger. Okay. If they're a little too big and it's to the point where it's not really working, then well, you'd have to go back and maybe glue paper on top of it, which maybe might not be as easy, but this could do that. Okay. So I'm going to fold these in, and oh, I have 6 teeth and 6 gaps, just like that. I folded mine. You could tear them off if you want. It might actually make it work better to tear it off. Yeah, I'll go ahead and glue mine. No, terrible glue. Anyway, put that to the side.
I got one. One thing. Sarah, how's your? Oh, look at mine. I just rolled up paper and then glued legs to it. My thing. I was lazy to be cylinder, so I just rolled up paper and glued legs to it. No, the table, I probably would have been better.
No, I would have died if I could do that.
What are you trying to say?
You know, you would have died.
I'd rather be thermodynamic.
All right. In the thermodynamics of the air, you can request. I'm sick. I didn't know.
One of my circles.
Okay, Sarah. It looks interesting. I would put that up on the wall in Hallmark. It's $2,000.
Thank you.
You just exchange it. It's better than a nail on the wall. I think it's a good teaching.
We're eyeballing it. And no one can stop me. I can try it.
I would recommend it. I did try it and it didn't go well.
You know what? My eyes are incredible.
You wear glasses?
The glasses make my eyes. They give you more glasses. No, you're not more glasses. Of course.
I was hoping to see something about that. That's like, what is it? I tried to have
This will. Looks like
These are both. And then read just one. That's a bit too far.
Same thing.
Alright, so good walk around the room, put the guys out, you guys are doing a real good job on this. A lot of you guys are up to this point, some of you guys are getting up here. Okay. So, let's take a head a little bit. Okay. So, it still needs some kind of system that these can actually spin on, because there's nothing really attached to. Okay. Did you guys figure that out? How do you think I made them spin in place? Oh,
I made a bear.
what's what you did? Ooh, okay. All right, yeah, that's what you do it. Yeah, so let's actually, do you want me to show the box, please? Yeah.
This may or may not stay together.
Maybe the trumpets have one.
Alright, so I'm gonna show you guys Alyssa's method. Alright, what she did was on the baseboard, punch the hole through the baseboard. Right, so here's her central axis right here. Okay, then push a piece of paper through, spin it over, and hey, look at that. So stay in place and spins just like that. Yeah. So there's a solution right there. There's one way to do it. Nice.
Very similar to, I don't know, it's not gonna come together. It's like,
Anybody else have any other ideas? Oh, yeah. Yeah, Doctor had an idea? Or- yeah, you look over there and see what's got.
Like this.
okay, but how do I know that I'm like doing this? My flow broken.
Oh, and then, like, it's going to like sit over. Oh, okay. Yeah, you like that? Okay, so, yeah, here, I put that here. Yeah, so, I think that could work. I think that works.
The only thing I don't
Okay, so we got about 3 or 4 minutes left in class. Want to at least think ahead a little bit till tomorrow, so you guys are ready when you come back in. let me show you guys this model. You guys come up with different ideas for systems to make them spin in place. I'll show you guys the solution I came up with. Is to create, let me pop these off, flip them upside down. Okay. So I've got an axle system going on. So a couple of cylinders, like short type cylinders, one bigger than the other. Notice how these two are pretty big, and then these two are pretty small, like big radius, smaller. Yeah, I bet some of you guys came up with that idea too, right? And they're not too tight, not too loose. So it's like free to spin. So it's going to stay in place, right? One other aspect, like if you want to make this work really well, is see the fact that it sticks up a bit gives it a third dimension, which is actually really good because if everything's the same plane, then the paper kind of gets all in the way of itself. But if you can make this gear with the teeth in it stand up a little bit taller than the gear with the pegs in it, the pegs are actually coming up from underneath, aren't they? You see that? Okay. Then you actually have a three-dimensional object, right? So you got 3 dimensions working. Something like that. Okay. So since we only do have a couple minutes left in class, I'm going to stop this recording. You guys can find a good pause point. Stop